question show time. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. Now, a note of warning, this is the final episode of the season. So every summer from July to the end of July or beginning of July to the beginning of September, I don't do any live streams. So this is going to be the last episode, and then things will return in September. That said, I'm moving, and I'm going to have a pretty rough place that I'm going to be living. I'm going to be camping on a new property, so I probably won't have the best recording facility in the beginning while we build our new facility. So it could get a little weird in the fall when things return. But again, I'm recording this in early July, so when you see this, there could be some new news. Maybe the Super Heavy booster launched successfully. Maybe Jeff Bezos was able to go to space before Richard Branson. Who knows what the future holds? All right, let's get into the questions. Philip Thury. Hey Fraser, great channel. My question is, how far up the atmosphere can bacteria be found? Is it high enough that it can seep out into space? One of the amazing discoveries in the last decade or so was that bacteria can actually float pretty high up in the atmosphere, definitely in the tens of kilometers. I'm not really sure exactly how high they go and are they active bacteria at the highest altitudes, but definitely at above 10 kilometers, bacteria are eating, drinking, reproducing, and existing entirely in the upper atmosphere. And following on to your question though, does that mean that they can seep off into space? Not exactly, because if you're going to try to get out of the atmosphere and out into space, you still need to go on some kind of escape velocity, which is very fast. So you can fly around in the atmosphere, but once you get out high enough into the atmosphere, it's really hard. There's not a lot of atmosphere to keep you carried up. You're going to fall back down. That said, there are some events that could theoretically kick bacteria out into the rest of the solar system and maybe even the universe. And so this was a paper that came out from Avi Loeb and some of his students about 1.5 years ago. And the idea was that there are comets in the Oort cloud that are just barely being held by the gravity of the sun. They're so far out that the amount of the change in velocity that it would take for them to be able to escape the solar system is really tiny. And so you've got these comets that are way out there. Some event happens, causes them to fall into the inner solar system. They pass through the Earth's atmosphere, and this is the key. So they would actually have to go right through the Earth's atmosphere, scoop up a bunch of bacteria, sort of, hitting the windshield of the comet, and then the comet would fly out into the rest of the solar system. It would interact in some kind of three-body interaction with, say, Jupiter or something like that, and it would be kicked out of the solar system into an interstellar trajectory. It would become an interstellar object like Oumuamua or Borisov. And so you'd have this mechanism that would carry bacteria from the upper Earth's atmosphere out of the solar system. And it's thought that these kinds of events where a comet actually passes right through the atmosphere of the Earth happen about once every 100,000 years. So could you imagine that? Like you're sitting there and the comet is plowing right through the atmosphere. Like that would be intense. I would love to see that. Although that's pretty close to the planet as well. So that'll also be a little scary. But yeah, so that's a mechanism on how you could get bacteria out into the solar system and maybe out into other star systems out there in the Milky Way. And if you think of a similar process is happening around every star, around every habitable planet that has bacteria, that has an Oort cloud, and you've got this mechanism happening, maybe you've got this natural way that life is going from star to star across the Milky Way. Master Pack. Dear Fraser, I love space, always have. Am I wasting my life not going to university, etc.? What with kids and having to provide, is this just a life to have to accept, is not one to study now? I don't think that you need to define your life as studying, like going to university and then not studying. I think it's important to study all the time on whatever it is that interests you and whatever you want to do to kind of increase your skill set. And I think that we get wrapped up, really caught up in this idea that if someone's not going to give me a piece of paper that says that I did a thing, then it's not worth even starting. But that's ridiculous. I mean, you can go and you can take an astronomy textbook and you can learn everything in the astronomy. You can do all the labs. You can learn your way around the night sky. You can learn to operate a telescope. If you're into computer programming, you can access data sets. You can process images. You can search for different kinds of data. You can teach yourself the math. Like, there's an unlimited amount that we can learn about these subject matters. And having the piece of paper at the end, that will help you get a job if you're willing to go through the enormous sacrifice to become, say, a researching astronomer. But for most people who are into space, you want to learn more about the subject matter, but you don't necessarily want to destroy your career, have to move somewhere, go through the academic lifestyle. It's brutal. So I think that just in general, you should never have this mindset that is it just too late? No, it's never too late. You can build your own computer science degree where you go through and take every one of the classes that's done in a really good university, and you can walk out the other side with the same amount of knowledge, probably more than the people who paid $100,000 for the experience. So I think we should always be learning. I'm learning a bunch of things right now. Obviously, I'm still trying to learn Chinese. I'm learning about space. Every couple of years, I come back around and refresh all of my programming knowledge. So no, I don't think you should have that kind of a mindset. If you're into it, just start learning, and then you'll decide if you're not having fun with it or if you want to go deeper and actually get some kind of proper academic credentials. Dan Baker. Would it be feasible to terraform Venus via sending icy comets at it to both provide water and cause an ice age similar to what happened on Earth with the dinosaurs? Yeah, if you crashed comets into Venus, it wouldn't get you the outcome that you're hoping for. I'm sort of imagining Venus as this hellscape world with atmospheric pressure that's 90 times Earth, temperatures above 450 degrees centigrade, and you're hitting it with a bunch of comets and somehow you're making it better. You're making it worse. That's kind of crazy to make it worse. Think about what's going to happen, right? You're just going to be smashing these asteroids into Venus. If they're big enough, then you're going to be kicking up a shield of material, of debris in the atmosphere, and that will cool the planet down a little bit. But then all of that material is going to settle back down, and then it's just going to heat back up again. Now, if you're sending in comets are going to be vaporizing. You're going to get water vapor in the atmosphere, and as we know, water vapor is one of the most intense greenhouse gases that we know. So water vapor in the atmosphere of Venus isn't going to help cool the planet down. The way that you cool Venus down is you have to get rid of that carbon dioxide. And there's an insane amount of carbon dioxide. That's the problem. You've got to be able to lock that carbon dioxide away from the atmosphere. There's sort of two ways to do it. One is you put some kind of shield around Venus so that Venus receives no sunlight. And then the planet will naturally cool down, and eventually all of the carbon dioxide that's in the atmosphere will snow down onto the surface of Venus, and then you've got to do something with it. And so that's the part two, is that you've got to figure out some kind of way, probably through chemistry, to be able to lock away all of that carbon dioxide into some kind of inert element. So if you used like limestone on Earth is something that is, if you had various elements, I forget, like calcium, magnesium, you could break up and lock away the carbon dioxide, but you need like a lot. And so you'd have to find some asteroid that's made of pure calcium that you could use to lock up all of that carbon dioxide on Venus. But just crashing comets into planets just doesn't make them better. Prince Charming. Question, do you think that we could detect the existence of any intelligent life in the Andromeda galaxy? Sure, we could detect the presence of intelligent life anywhere in the observable universe. The trick is just that the farther things are, the more difficult it becomes. So the nearest stars to us, let's say you've got Proxima Centauri at like 4 light years away from us. That's pretty close. And so if you had, say, an Earth-sized planet orbiting the star, you had a really powerful telescope, you could observe the atmosphere of the planet, and that could tell you something. Or if there was some intelligent civilization on the planet and they were broadcasting their radio transmissions, then we could theoretically detect them from here on Earth, especially if they were broadcasting directly at Earth. If they had like some kind of laser that they were pointing at Earth, we could probably detect it. But once you go farther out, say to the other side of the Milky Way, we're having a hard time even just detecting stars on the other side of the Milky Way. And the Milky Way is like 170,000 light years across. Andromeda is like 2.5 million light years away. And so you would have to have a very, very ambitious technological civilization in Andromeda that has built up some enormous laser that they're beaming in a coherent path directly at us that we could actually detect it. So in theory, there are some other techniques as well, like gravitational microlensing. You know, we're just getting to the point now where astronomers think they're going to be able to start detecting, or at least understanding, whether or not there are planets in Andromeda. And so you could imagine some future really powerful telescope is able to detect stars in Andromeda dimming slightly through gravitational microlensing. And maybe they can detect planets around those stars. And maybe they have some way of detecting technological objects, megastructures orbiting around the planet, orbiting around the stars as the transit is happening. But again, it's all very, very difficult. Like, we're going to have a hard time finding life within 100 light years of us right now. So we'll finish that search first. Dasha Bingham. Could intelligent aliens perceive time differently and thus, unlike humans, feel the short-term and long-term in equal urgency, avoiding disasters like climate change and self-destruction? I mean, we really don't know how other civilizations, how other alien species, alien minds would experience time differently from us, but we do have a sense that other animals here on Earth experience time differently from us. And we can experience time in different ways depending on the situation. If we're having fun, time seems to go really quickly. If we're in a lot of pain, time seems to go really slowly. And so even for us as human beings. But there's a situation where you can absolutely get a civilization that can experience time in different ways. And that, of course, be something that is artificial in nature. I mean, we know that you could take a computer, you can have really how quickly the computer thinks just depends on the clock rate of the computer. And so you could have some future civilization realize that the best time to exist as a technological civilization is when the universe is the coldest. And that'll be in the far, far future. So there might very well be technological civilizations that realize that the universe is just too hot right now. So they go into a really reduced clock speed. They wait out till the temperature of the universe is close to absolute zero, and then they wake up and then they get to work. And so that's an interesting idea. So I would say that if you wanted to have some alien species that experiences time differently, it would probably be something that is artificial in nature, technological in nature, as opposed to natural. Because, you know, we experience time partly just through our biochemistry, as well as the natural cycles of how things work on Earth and just our natural environment. But I mean, who knows, right? Who knows how aliens will function? We still haven't seen any examples yet that we can even investigate. CLC, why do spacecraft use so old processing hardware? I get that they can't use 2021 hardware, but so many use like 10 to 30-year-old stuff. I wouldn't say that spacecraft use 10 to 30-year-old stuff when they're being prepared for launch. They use relatively new hardware. It's just that spacecraft are designed to function for very long periods of time. The Hubble Space Telescope, for example, is like, 35 now? And so people were working on it for a couple of decades before. And so when they finally settled in on the computers they're going to use on Hubble, and that's like its brain, so it's really hard to remove its brain, you are looking at a very old piece of hardware. New Horizons was being constructed, took a couple of years, and then it flew for 10 years to get to Pluto, and then has been operating for multiple years after that. And so you're definitely looking at gear that is, say, 15 plus years old. Same thing with Cassini, same thing with Galileo. But when you've got like a newer spacecraft that is developed very quickly, you're looking at, say, TESS. TESS was designed and launched within a couple of years. And you've got a couple of other examples of spacecraft that are coming together that quickly. So they're using fairly modern equipment. Now, that said, you don't want to use the absolute bleeding edge because you want to use stuff that has been tested and proven in space. You know, we don't know how like the hottest new Threadripper chip is going to work when it goes to Mars. With a higher nanometer density, is it going to be able to function when it's getting blasted by cosmic rays? And then the other issue is the environment that's going to be working in. If you need something that is more space hardened, you're going to look for something that's more tried and true, more shielded. So I promise you, whenever a new spacecraft is being developed, the engineers look at all of the possibilities and then they select the hardware they're going to go with based on the requirements. And they're always going to try to use the fastest stuff that they can. Perseverance has arrived on Mars, say 9 years after Curiosity did, and yet it is a dramatic upgrade in terms of its capabilities than even Curiosity. So the march of progress goes on. It's definitely delayed for spacecraft, but it's not that bad. Zapfan, am I excited for the Bezos versus Branson space race? Yeah, I mean, I want it to be safe. I don't want anybody to die, so I would prefer that they took their time and made sure that they were absolutely safe before they took to space, especially the fact that Jeff Bezos is bringing Wally Funk on board, who is an absolute treasure, and it would suck if anything were to happen to her. So yeah, as long as they're safe. It's funny, I got into an argument on Twitter about, and someone didn't sort of understand, I guess, what my perspective was. And so someone was going into just how complicated it is to keep astronauts alive on the International Space Station, and just the nitty-gritty. It takes thousands of people to keep every astronaut alive on board the International Space Station. And I was sort of following up on that, as, you know, people always talk about, like, are the billionaires going to just try to escape Earth? They're going to go to Mars. They're going to live large on Mars, escape crappy Earth. And the reality is no way. Earth is the best. Mars, the moon, deep space is just pain and suffering on the knife's edge of survival, supported by thousands of people. That Antarctica is a paradise compared to the moon, Mars, or space itself. And so it's not like some billionaire is just going to go, well, I'm done with Earth. I'm going to go and retire on Mars, and that's going to be better. So long, suckers. It's not going to happen. So I thought that was really funny. I think a lot of people are frustrated by this billionaire race, Bezos, Musk, Branson. But I think like billionaires spend money on really stupid things. I mean, if they're spending it on helping humanity reach out to the solar system, I think that's a good thing. And remember, all that money that gets spent on space gets spent back here on Earth. Jonathan Allen, I was out in the woods this weekend and I saw a ton of lights moving across the sky. How many satellites are visible with the naked eye? If you saw a ton of lights moving, you probably saw the most recent Starlink launch, because after they launch and they're moving up to their final operational altitude, you can see them in this big long line in the sky. But if you just saw lots of satellites, you know, now we have both the International Space Station as well as the Chinese Space Station. So you've got two really bright space stations that are visible in the sky, although the Chinese one isn't anywhere near as bright as the International Space Station. But on any night, like here in Canada, during the summer, when the satellites are well illuminated, you can see a satellite almost all the time. So wherever you look in the sky, if you sort of wait, look around, you can see some satellite moving across the sky. And it's kind of cool. Starlinks are just beyond vision with the unaided eye once they're in their final operational altitude, unless you live in like really dark skies and you're using a telescope or binoculars. So from what I understand, you can see a few hundred satellites that are visible in the sky. And I know that people are building these giant mega constellations coming up over the next couple of years, but it really just depends on how bright these individual satellites are going to be, whether or not they'll make any change. I mean, a lot of people are really worried about these mega constellations destroying our view of the night sky, and chances are they won't. You could go out in dark skies, look up, and you won't see this matrix-like grid of satellites moving across the sky. The people who are affected are the astronomers, especially the professional astronomers, who will be taking their science data, and in their telescopes, the satellites are absolutely visible, and they cause streaks that run right through the galaxy they were trying to observe and ruin all those frames. So as more and more of these satellites go up, the more difficult it's going to get to be able to observe the night sky from here on Earth. More questions in a second, but first I'd like to thank our patrons: Nathan Conklin, Simon Keynes, Kakosaraf, and the rest of our 817 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universe today. Nuno Fernandez. Would you like to go into cryosleep and wake up 500 years from now and learn about all the science that have been discovered? It's a good question. People always ask me, like, would you prefer to go forwards in time or backwards in time? And for me, it's always forwards in time. I would way prefer, 500 years into the future. That would be awesome. I would love to do that. Now, obviously with a few caveats, like you've got to promise me in advance that there won't be an apocalypse and I'll have to live through a post-apocalyptic agrarian society filled with pain and suffering. Like, you know, I want like a future that continues on where interesting new technology is happening. Yes, that would be awesome. Would I do that? Would I like say goodbye to my friends and family, wife and children? Probably not. I think I'm going to stick with my plans for my robot body instead, and then I'll be able to do both. I'll be able to enjoy time here on Earth, and then I'll be able to shift over into my beep boop robot body and last 500 years. That's the plan. Lewis Nelson Smith. I'm disappointed with Hubble and the James Webb delays. Can we develop smaller scaled telescopes that would be better than land-based telescopes and quicker to send up into space than James Webb? Well, the problem is that a big telescope going to space is complicated, expensive, and a very delicate operation, and you have to take your time. That's the problem. And so, like, the Hubble Space Telescope is a 2.4 meter telescope, and then compare that with the biggest telescopes that are on Earth right now, say the Keck observatories at 10 meters. But Hubble is like the size of a bus. It's a very big machine. And the only spacecraft that was capable of launching into space was the space shuttle at the time. James Webb has a telescope main mirror that's like 6.5 meters across. And it is really big. And the only way they could make this thing work was to fold it up into an Ariane 5 fairing. And then have this really complicated mechanism that makes the whole thing fold out. And it was a lot of that technology that caused the delays. So I think lessons were learned in the creation of both Hubble and James Webb. You've got examples of spacecraft that launched fairly quickly and did a great job, like Kepler, although its reaction wheels died. So maybe that's a bad example. Things like Herschel. You know, you've got a fairly simple design. It kind of looks like the Hubble Space Telescope, as big as will fit inside the fairing of your rocket. It's a tube, it's a mirror, and it goes to work. The next one that's going to be coming on that class is probably the Nancy Grace Roman Telescope, which is the same size as the Hubble Space Telescope, but it's going to have a much wider field of view. Same thing, tube, mirror, goes inside a rocket, flies to space. Doesn't have to do any of this really complicated folding, which is what James Webb is going to do. But I think to get to those really next level big space telescopes, we just need bigger launchers or better folding or space-based construction. Probably space-based construction is the way to go. So I think James Webb is going to be the last telescope which is built down on Earth, folded up nice, flown to space, unfolded. We saw it was a very complicated, very expensive affair. So the next generation of giant space telescopes are going to be constructed in space. You're going to send up the main computer bus, and then you're going to send up the one part of the mirror, one segment of the mirror, and then another segment. And then the bus is going to have little robotic arms, and it's going to put all of the different mirror segments together and align them properly. And it's going to build out its solar panels. And so, you know, that technology is relatively straightforward. I mean, we saw that astronauts were able to build the International Space Station out of a whole bunch of pieces. So imagine a space telescope that's built out of a bunch of pieces. If one piece fails, don't worry about it. Just launch another piece. So that's probably what the future holds. But that's a whole new series of technologies to develop, of roadblocks to go through, of delays to go through. The other path that's moving quite quickly is the development of ground-based observatories. I mean, the next generation, we're going to see 30-meter telescopes, 39-meter telescopes down here on Earth, which are going to leapfrog what James Webb is capable of, definitely what Hubble is capable of, start to get on par with what some of the next generation big space telescopes will be able to do. You know, the extremely large telescope is going to be able to observe habitable worlds, Earth-sized worlds orbiting sun-like stars out there in the universe. Scientists always want the best possible instrument they can get their hands on. And that often means that you've got to be ambitious about what it is that you create. And whenever you're ambitious, there's the possibility that you're going to have failure, that you're going to have delays. And that just goes as part of the territory. So you shouldn't be frustrated. Like, obviously everyone's frustrated. Like, nobody wants James Webb to take longer than it did. But that's what you get when you reach far. Verdadero. Hey Fraser, do you think we had some knowledge about the universe thousands of years ago that was lost and still not found with all our modern tech? Perhaps some rare event or debris still buried. You know, the capability of modern science to observe the universe is incredibly more capable than anything ancient peoples ever had. I mean, we have telescopes. Like, we didn't know that Saturn had rings until the 1600s when Galileo first turned a telescope on Saturn. We didn't know that Jupiter had moons and bands across itself. We didn't know that the Milky Way was made up of stars until, again, Galileo. We didn't know that Venus went through phases until Galileo. So it was really the advent of the telescope that gave us our modern understanding of the night sky. Now, there have been events that would have happened in antiquity that have never been experienced by modern astronomers, like a relatively close, very bright supernova that went off in the sky. It's been 400 years since the last bright supernova was seen, but imagine one that was really close. Maybe just a couple of hundred light years away. It would have happened in the eyes of some human at some point in the last several 100,000 years that humans have been around on Earth. Think about that thing that I talked about at the beginning, where a comet passed right through the atmosphere of the Earth. Like, there were ancient Homo sapiens around on Earth to witness that kind of event. And also the ones that came within 100 kilometers of the atmosphere and within 1,000 kilometers of the atmosphere. So we always see these tiny little dim comets that are really far away, but people have been around to see just terrifyingly bright, close comets. But I'm not sure that they would have any kind of knowledge about what it is that they were seeing. There would have been very bright asteroid strikes on the moon that would have been visible from people here on Earth. So I think there are a bunch of really rare events that would have happened very close to home, but they wouldn't have had the kinds of tools to help them analyze what it is that they were seeing. So no, I don't think that anyone has had as much knowledge about the universe as we have right now today. And in 10 years from now, I would be able to say the same thing, that we were living in the dark ages compared to what we know now. And as we gain more knowledge, better technology, better telescopes, better instruments, we learn more and more. Vilk. How would a civilization close to a black hole experience time and perceive the age development of the universe? Thanks for the job you do. Kind regards from Norway. Yeah, this is pretty cool. So if you were a civilization that was living relatively close to a black hole, then you would be in the black hole's field of time dilation. And we saw in the movie Interstellar, right? Matthew McConaughey and team goes down to this planet orbiting this supermassive black hole. They are down there for a day, and when they come back up, decades have passed for the rest of the universe. And so imagine that was your home. You would be watching the universe move at high speed. You'd be seeing other planets zipping around the black hole. You would be seeing stars being born and then die. You would see the cosmic microwave background radiation would be blue shifted into a higher spectrum, maybe to the point that you could have solar panels that are absorbing the cosmic microwave background radiation because it's been pushed into, say, even like the visible spectrum. So it really just depends on how close you are to that black hole. And so it's been theorized that if a civilization wanted to live a really long time, they would huddle up close to a black hole. Now, one of the advantages of being close to a black hole is that you can throw matter into the black hole. You can harvest the energy as material is kicked back out of the black hole. There's bursts of radiation that are going to happen. But then you could just experience an accelerated universe because of the time dilation. So it's a pretty cool idea. And it's often been considered like the last comfortable place to live after the rest of the universe has cooled down. And so we talked about at the beginning about those civilizations that are waiting until the universe cools down. So maybe what they do is they wait, and at the very end, they set up shop around a black hole, tune the time dilation exactly how they like it, and then live out billions, trillions, quadrillions of years in an accelerated rate, doing whatever they do. Francis Tony, do you think there's a business model for Starship at the moment? Lots of R&D and infrastructure costs being spent, worried they won't survive the gap until it could be really useful, and Starlink may not cover it. SpaceX built the Super Heavy booster number 3 in 6 weeks. This is the biggest booster rocket that's ever been made, bigger than the Saturn V by a lot. It took them 6 weeks. They just built it. They stacked up steel, put in a bunch of fuel tanks, and they think they're ready to go with ground tests. Booster number 4 is probably the one that will try to do hops and eventually go into orbit. Like, if Starship works, this is the big if, right? Then the rockets are cheap to make and they're really cheap to operate. The cost is really just the fuel, which compared to the cost of a regular rocket is a fraction of the price. And so the business model for Starship is everything. Like, would you pay $400 million to get your satellite launched on a Atlas V? Or would you pay $1 million to get your satellite launched on a Starship, on a Super Heavy? It's orders of magnitude cheaper than any other launch facility out there. Even these small ones like Rocket Lab, like the cheapest launcher is going to be the fully reusable rocket. It's kind of like where the business model sort of taps out is they will run out of things to launch. They will launch every single rocket, every single satellite, every single mission that anyone has ever wanted to do, and then they'll have to think of clever new ideas for what to launch with Starship. So yeah, I think the business model for Starship is going to work really well. Again, compare that with the development time of how long it took to build the SLS, right? Like, it's crazy if it works. And if it doesn't work, then yeah, SpaceX has some problems. RJQ, are you disappointed that Trident was not picked? We've only been to Neptune once and don't even have images of all of Trident. Seems like a visit to Neptune is slipping outside of our lifetimes. Yeah, I'm disappointed. I mean, but how can you choose? Like, would you like a mission to the atmosphere of Venus? Yes. Like, to do like really good scans of the surface of Venus. Like right now we have scans that are, say, 100 meters per pixel, but we could get down to 1 meter per pixel. It could tell us, is there plate tectonics on Venus? Is there still volcanism on Venus? Why Venus? What happened? Why did it go so bad? Yes. That's Veritas. Would you like a probe that would fall through the atmosphere of Venus, sampling the atmosphere at different levels, maybe helping build up the case from an atmospheric sense of what happened to Venus? That's Da Vinci Plus. Yes, please. Would you like a mission to Io? Like, nobody's been to Io. We've got some images from Galileo, we've got some images from the Voyagers, but nobody's gone and put an orbiter around Io and really imaged that planet. We would see just the craziest volcanoes at different perspectives from orbit. Yes. And would you like a mission to Neptune to see Triton and do a quick flyby and see some more views? I mean, we know that Triton probably has cryovolcanism in the same way that Europa and Enceladus do. Yes. So, like, it is not fair to ask me to choose which one of these missions I would like the best. Like, I'm serious. Like, if I was on the committee that had to vote, I'd just be like, I'm out. Like, I can't vote. Just you guys decide. Because I can't choose, because I want them all. And I think that's what I hope, is that these missions will just get kicked down to the next cycle. And maybe if Starship is able to launch these things for cheap, then maybe suddenly we get all the missions that we want. So here's hoping. Cryptolicious. Fraser, what do you think that after 50,000 generations of humans, that we are the generation able to find life beyond Earth with the next generation satellites? It is kind of amazing that we are poised at this time in the state of all human history that we are finally able to at least try to answer the question of whether or not we're alone in the universe. But I mean, there's a million of these kinds of questions. Like, it's thanks to our science that we're able to have a conversation with a computer. I mean, a fairly dumb conversation with a computer, but it's getting better. To be able to hold all the knowledge of humanity in your hand. To be able to watch some journalists talk about space from wherever you live in the world. So, I mean, just all of these technologies that we've come up with so far just enable more and more of our understanding of the universe, of our capabilities to be able to do things faster and better. And being able to find out whether or not we're alone in the universe is just one of these amazing things that we're able to do now. Arjone, will the new LIGOs going online improve our resolution? How far can we hear collisions, Kagra, etc.? Yeah, right now we're in a bit of a downtime with the LIGO observatories while they're doing a bunch of upgrades on these various gravitational wave observatories. They put a bunch of new technologies in, ones that improve the sensitivity. They've got this thing called quantum squeezing, but essentially using quantum mechanics, they're able to, and I forget the exact way this works, but essentially you can know the position or the speed of a particle, but you can't know both. And so you can they're pushing this uncertainty in one direction, that it gives them the kind of information that they want while sacrificing the other question. And so they're able to get a much larger volume of space that they're going to be able to observe. And they're going to be able to observe more interesting objects. They're going to be able to see stuff happen more often. So up until this point, we saw maybe one gravitational wave event every week. Now maybe we're going to see one black hole neutron star collision every week, and so on and so forth. So it's a pretty exciting time for gravitational wave observatory. And I just saw today that the Europeans have approved their next generation gravitational wave observatory. It's a 3-legged gravitational wave observatory, sort of like the way LISA is going to work, be this triangle with signals going around inside of it, with much longer arms than we have with LIGO. So what's great about gravitational wave observatories is each one that gets added to planet Earth, there's, as you say, Kagra, the one in Japan, there's one that's going into India. Each one just improves the overall capability of our ability to detect gravitational waves. And this is just going to continue. And as the space ones come online, we just get more and more sensitive about detecting gravitational waves. All right, those were the questions this week, and those were the questions for this season. So once again, this is the last episode of the 2021 season. I will be back in September with brand new interviews, question shows, and other new interesting ideas that I'll be working on over the summer. So I hope you all have a fantastic summer, and I will see you all in a couple of months. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks as always to Chad Weber and Nancy Graziano.